You see, we learned that there are three types of netting. Static net, as I said, it is one-to-one net. Let me draw a diagram and then I'll explain you static net. You see, we have a router. This may be your house router or it may be in your enterprises, in your company. Now you are connected to many devices in your house through Wi-Fi or through cable. Let me put it like this. You have a switch and you have some computers. And this is the router where we are going to do NAT configuration. And we call this side of the network as local area network, LAN. LANs will always have a private IP address, 10.0.0.1, 10.0.0.2, 10.0.0.3. And here as a gateway, let me give 10.0.0.10. And I would like to name this interface as, let's say, Ethernet 0. And now there is another interface connecting to the cloud. The cloud, we call it as wide area network side, WAN side. And I would like to name this interface as E1. Let's say your ISP has given a public IP address 11.0.0.1. Is 11 public IP address? Yes, it is. Fine. Now, static NAT is one-to-one, I told you, meaning for one private address, I'm going to dedicate a public address. And this public address, I will not give to anyone except that one computer inside. Inside, we have three computers, right? 10.0.0.1, 10.0.0.2, and 10.0.0.3. And this one public address, I'm not going to give to all. I'm going to give to one single computer inside in the LAN. Let me name these computers first. Alpha, beta, gamma. Now, let's say this alpha is a very important person in the office. So you want to dedicate an IP address only for alpha. So what I do is I can use this address on the interface, or I can buy another address from ISP. Let's say ISP is giving an address 11.0.0.50. See, already ISP has given you one address which you have already assigned to an interface, assigned to a port. Apart from this address, you have purchased another address. Where is this address assigned? Nowhere. Nowhere. It's not assigned anywhere. But it can be used as the mapped address. What does that mean? Mapped address? Translated address. So let me repeat the story again. For an address to be used It need not to be there on the interface. Not necessary. It can be an address like this, which is nowhere on any interface, but can be used for translation. So what I do, I give 10001 a dedicated address 110050. This is what called as one-to-one NATing or static NAT. This 110050 will never be used by beta or gamma, only alpha. Even if that address is not being used by alpha, even the address is not be used by alpha, beta can't use it, gamma can't use it. It is only for alpha. Let's say you have a computer in your house and that is only for you. Even when you are not in home, you don't allow your sister or brother or son or daughter to use it. That is one-to-one. Some parents don't allow their cell phone to be seen by children. They don't allow. They lock it and keep it. For them, it is one-to-one. One-to-one. So, what about beta and gamma? You need to do something else. You may need to buy another IP address, or you can do another type like dynamic NAT or PAT, port address translation, which we will talk about that later. Now we are focusing on first type of NATing called static NAT, which is one-to-one. Let's focus only on that. Do not worry about beta and gamma, how it will communicate. Not necessary now. Alpha needs to go online. To go online, they need alpha need a public IP address. For that, I have dedicated address to be used only by alpha. This type of NAT is what called as static NAT. Now, how we are going to do this in the lab and test it? I'll have another router here. Instead of this blue color cloud, I'll have another router here. This router is going to have 1100, let's say 100. This is your ISP. Instead of ISP, I'm having a router. And I'll have a loopback interface, let us say some address 1.1.1.1, like Yahoo, Facebook 2.2.2.2. Now, this ISP knows only 3 network. What are they? ISP knows only 3 network. What are they? Is it very difficult question? Please participate. Only these 3 networks. ISP don't maintain routes for private network. You don't have route for private network 10.0.0.0. And I'm also not going to write any static route here for 10. Why? In real world, we will not have any static route for 10. ISPs never maintain private networks. Saravana, did you understand this? So now what is when the NAT is configured on this router, the traffic that is received from alpha will be seen by ISP like this. It'll see like this: source 110050. Destination is 1.1.1.1. Let's say you are pinging from this computer alpha. You're pinging from alpha. Alpha will send it to the gateway. Gateway will check the route to reach 1.1.1.1. This is our router. We usually write a default route pointing towards ISP. So packet will go to ISP, but before going, what will happen? This address will be changed to 110050. This changing is what we call it as NATing. Originally, when packet was coming out from this computer, the source address was 10.0.0.1 and destination was 1.1.1.1. But after translation, the source address has changed to 110050. This guy knows about 11, so it can respond back. And any traffic coming to 11.50 will be reverse NATed to this address and it will be delivered to alpha. Did you understand this flow? Okay. As I said, I'm going to take some computers first, connecting to this switch. Alpha, beta, gamma, 3 computers. And these 3 are going to be connected to a router from this switch. And that router will be the gateway for these 3 LAN devices, alpha, beta, and gamma. And that is connected to another router, which is like an ISP for us. So I'm just naming it as ISP, and I'm naming this as Edge. And this computer is going to have 10.0.0.1. And this interface is going to have, this is all I'm writing for your reference. When you do, you no need to do all this. Board works. 10. And on the other side of the router, I'm connecting the WAN facing interface, which is G001, with an IP address on the interface 11.0.0.1. In here, this side, it's going to be 11.0.0.100. As we discussed, we are going to have some loopback for testing. Okay. And now next is, let us first finish configuring this PCs with the appropriate IP address 10.0.0.1. And what is the gateway? Someone tell me what should be the gateway? 10. Router's address. And now on the second PC, 10.0.0.2, 10.0.0.10. The third PC, right. So next is the router configuration. Let me finish this edge first. Enable config t hostname edge. Good practice, you would put this command no IP domain. You know why we are typing this, right, Sarona? So that when we make some mistake in typing, it won't make us wait. Now on G00, I'm going to assign this IP address. And on G001, we have put this IP address. So we have finished configuring these two routers with IP address. Now this is our edge router. This will always have a default route towards ISP. Of course, you know, when we have a router in our home, our router will point towards ISP to go to anywhere in the internet, isn't it? Is there any other option? No other option. Anywhere you want to go. You want to go to Yahoo or you want to go to any newly developed website, whatever it is, whether it is popular and unpopular website, you should go to ISP only. So we have only a default route always on the edge router, IP route, any network, any subnet mask. It will be pointing towards your ISP's IP address if you know. If you don't know your ISP's IP address, you can put your exit interface address, which is 0.0.1. Okay. Now this is how the routing table will look. Why I don't have 11 network? Because the line protocol is down. Why? This side we have not said no shutdown. We already gave IP address, but why it is not showing in the routing table? Because the link has not come. Line protocol, you see, show IP interface brief. Because I said no shutdown, this has come up. But the protocols are not getting response from the opposite router, the next router ISP, because we have not configured it. That is why it has not come up. When it comes up, it will come in the routing table, including your default route. Now let us go to ISP route. All right. Interface G000. Am I right? Yes. No shut. Now, because I say no shut here, if you go to the other router, the line protocol will come up. And now in the routing table, you will see two more routes. One is your static route, another one, 11 network. See, static route and 11 network. Fine. Now going back to ISP. ISP router IP address is 11.0.0.100 0. Copy. Next is interface loopback 0. We put this address. Interface loopback 1. We put this address. Interface loopback 2. We put this address. Let's check the routing table. They're all directly connected. Show IP route. Routes are there. Now you see, ISP can ping the customer. This is customer's address. Likewise, customer edge can ping customer edge can ping ISP, can also ping the other networks of ISP. See, how is this possible? Let me explain you. You see, we have a default route. So when I ping from here 1.1.1.1, tell me what will be the source IP address of the packet? Destination is I'm pinging this address, so it will be 1.1.1.1. What will be the source? Correct. That is what I want to hear. 11. Because this guy knows 11 in this link. Because this guy's routing table, ISP knows 11, 1, 2, 3. So it is able to respond back. But if I will ping from alpha, the packet will come with the source address 10.0.0.1, and because there is no natting, it will go as 10.0.0.1, but there is no path for 10 known to this router, so this router cannot route, cannot reply back. Do you want to see that? Let me show you. If I ping from here, ping 1.1.1.1, I am not able to ping. My gateway pings, but the insiders can't ping because insiders address is a private 10.0.0.1. ISP router don't have root for this 10 network. This is how in the real world it will be. If you don't write NAT statement, our traffic will go. But this guy, he don't know to reply back because there is no root. That is why we are going to change the source and we are going to remove the source and we are going to write 11.0.0.25. That is the address, let's say, I purchased for giving a dedicated address for alpha. I buy this address and say, router, you NAT it. If any traffic coming from this address, if there is a match, you have to put this address like this. Now the traffic will go here to this destination this will try to reply to which address? 11. It knows 11 is in this path. It will reply back here. Now when this router receives packet for 11.00.25, it will change the address, the destination address, to 10.0.0.1 and send the packet here. You understand? While going, the source address was getting changed. While coming from the edge to the alpha, the destination address is getting changed. Why? Because this ISP, when it responds, it will respond from source 1.1.1.1 to the destination 11.00.25. When the packet comes, it says you have to remove this 11.00.25 and put back 10.0.0.1 so that it will go to the original sender. Did you understand this? With natting, you will be able to ping. After I finish natting, this ping should happen. Did you understand that point? So, in our edge router, you should not write route for Yahoo, Facebook. On Earth, you will have 1 million destinations. Will you write 1 million routes? No. You just do the natting and have a default route. That is enough. Now, before natting, I would like to go to ISP. Saruna, are you listening? I'm in ISP router. I'm putting on command called debug IP packets. This command debug means dig deeper and show all the conversations. By default, to avoid the buffer stage, it won't show all the conversations behind the screen. See, when I was pinging from there, when I was pinging from here, actually the packet came here, but you did not receive any logs here. But now after putting this debug, you will be able to see the log. Let me ping again. You see, I ping, the packet will come definitely here. You see, you already see. Packet is coming from the source, alpha, to the destination, this one. But when the destination tried to respond, see, when the destination becomes source, trying to respond, what happens? Unroutable happens because the router don't have route for 10 network. You see, this is the reply packet. This is the incoming packet. It is coming with the source to this destination, and when it is trying to reply back, the destination address will become source and the source address will become destination. But for this destination, there is no route. There is no route for 10. That's why the packet is unroutable. Router is not able to reply back. So what will happen there? The output will be request timed out. Why? Because that guy is not giving. ISP don't know how to give. No route. So not giving. This is not getting. So the timeout happens. Waiting, and timed out. Waiting, and timed out. Now after natting, you will be able to ping because the source address will be changed to 11 network, which is known to ISP. Okay. Now we are going to see the steps to do natting. What are the steps? First thing is you have to write which side is inside and which side is outside for natting. This is the inside. This interface is inside. This interface is outside. We have to define the inside and outside. That is the very first step for all three type of NAT. You should do this. Because I'll be using the same topology, For the other two type of NAT, I will not be repeating. You should know that this is the very first step for all three type of NAT. NAT inside on G000, NAT outside on G001. Why are we doing this inside and outside? Because when we write the NAT statement, we will write like this: IP NAT inside source static, because we are writing static NAT. So static NAT from which address? 10.0.0.1 to which address? 11.0.0.25. See, I'm saying if a packet is coming from inside interface with this source address, you map it to, you change it to this address. All the IP packets, you change it to this address. Did you understand the meaning? This is what we do it on global configuration mode. This we do it on interface. This we do it on global configuration mode. Did you understand? Is there any doubt in this commands? Why are we writing this? What is the meaning of this command? Do you have any question like that IP NAT inside source? Source is inside first. Comes source and then comes inside. From inside the traffic is coming, the IP traffic. No, I'm doing wrong. IP NAT inside source. IP NAT inside will come. Packet coming from inside, and inside is the source. If it is true, statically NAT this address to this. Okay. If I do this, the ping will happen. Let's go. Let's go verify. Now I'm going to configure the first step. First step is go to the interface. IP NAT inside. Next, go to the next interface. IP NAT outside. Don't forget this command. This is a common configuration for all three types of NAT. Sometimes people forget this one and do all of the rest of the thing, and then they say NAT is not working. Something is wrong in this router. The router has got bug. Okay. Next. IP NAT inside source static alpha, you translate to 20.0.0.25. See, this address is nowhere on the interface. You know very well, I have not assigned this 25 address anywhere on the interface. I just put one only. You can use an address, sorry, not 20, 11. You know very well, I don't have anywhere 11.0.0.25. I have only 11.0.0.1. But I want to use a dedicated address for alpha, so I'm not using the interface address 11.0.0.1. I am giving this dedicated address which I purchased for alpha. Now let us verify this before we ping and test. You see, show IP NAT translation. This is the only command you need to know to verify NAT. This is the only command you need to know to verify NAT. It says if any traffic is coming from this address, it will be translated to this address. But so far, no translation happened. Now I'm going to ping again. This time the ping will happen. I will also take you parallelly to the debugs which we enabled. This is the debug command. If you want to stop the debug, we'll need to type undebug all, or you can type uall. Anything is okay. But I want debug now. Let me put the debug again. I'm going to ping from here. Now you see the packet is coming from 11.0.0.25. It is not coming from 10.0.0.1. You see, the packet comes from 11.25 and the reply goes to 11.25. There is no unroutable problem now. Even if you go now, you see, you can see the replies. Try again pinging. Now you see again you're getting packets. Yep. So translation is happening. Let's stop the debugs. You are able to ping now. And let's see the NAT table. NAT table on the edge router again. Earlier when I showed you, you did not see many output. You saw only one static mapping. But now you can see one ICMP packet came from this address, I translated. Again, another packet came from this address, I translated. Or it is just going to the destination this. See, it shows how many packets got translated and what is the protocol. Let's do one thing. Let's enable telnet and check. User ABC, password ABC. Now let us telnet. Telnet 1.1.1.1 ABC. ABC. Now let's go and check the edge router. Do you have translation record? Yes, it says it was TCP protocol and 23 was the port number. Did you see now? I'm sorry. Now, will I be able to ping from beta and gamma? No way, because we did not translate for 10.0.0.2. So pinging from here won't work. We transfer from only one computer alpha. Questions, please. Questions? Anyone has got question? Static net? Okay. If no question, take